External SSD. The external SSD requires zero knowledge of your computer's internals. It lives outside the machine. You plug it in via USB, use it, unplug it, put it in your bag, and go. No setup, no stress, just storage that follows you. What it does is store your files, photos, videos, backups, entire project folders, without touching the inside of your computer at all. Think of it as a portable vault that goes where you go and asks nothing in return. Why people love it comes down to one word: freedom. It works on any device with a USB port. No installation, no screwdrivers, no opening anything up. Photographers hand files off on set. Video editors carry entire projects between studios. And for backing up your main drive, nothing is simpler. Plug in, drag, done. But here's the part that catches people off guard. An external SSD is only as fast as the port you plug it into. Connect it to an old USB 2.0 port, and those impressive speeds on the box mean absolutely nothing. You're also paying more per gigabyte than internal options. And if it gets lost, everything on it is gone. No recovery, no second chance. Who doesn't need it is anyone whose computer never leaves the desk and just wants more internal storage. There are better, cheaper, and faster ways to get that. SATA SSD. Here's where things get interesting, because this is the upgrade that changes everything for most people. A SATA SSD connects to your motherboard through a SATA cable. If you've ever seen an old laptop hard drive, this looks almost identical. But what happens inside is completely different. No spinning platters, no moving parts. Just fast, silent storage doing its job every time you hit the power button. Why people love it is the transformation it causes. Drop one into a machine running on an old mechanical hard drive and everything changes. Boot times that took 2 minutes fall under 20 seconds. Apps that used to crawl are just there. The whole machine feels different. People do this upgrade and genuinely think they bought a new computer. They didn't. They just finally gave their old one what it needed. The strengths are consistent, affordable, compatible with almost every desktop and older laptop in existence, large capacities at prices that make sense. Installation is manageable even for first-timers. The limitations matter though. SATA has a hard speed ceiling at around 550 megabytes per second. For everyday tasks, you'll never feel that limit. But for heavy creative work and large file transfers, you will eventually hit that wall. And here's the part most people miss. The SATA SSD is not the fastest option. Not even close. But for the right machine, it is the most impactful upgrade per dollar you can make. That distinction matters more than the spec sheet. M2 SATA SSD, same performance, completely different shape. And this is where a lot of people make expensive mistakes. An M2 SATA SSD is the exact same technology, same speeds, same performance ceiling. But instead of a chunky drive with cables, it's a small stick roughly the size of a piece of chewing gum that clicks directly into your motherboard. No cables, no brackets. It just disappears into the board. What it does is identical to a regular SATA SSD. Run both through a benchmark and the numbers look almost the same. The technology inside hasn't changed. Only the packaging has, and that change exists for a very specific reason. Why people use it comes down to form factor. Laptops got thinner. Cases got smaller. There's simply no room in a slim modern machine for a 2.5-inch drive and its cables. M.2 was the answer. Same storage, smaller footprint, cleaner result. Now here's where people lose money, and this is worth slowing down for. M.2 is not a speed standard. It's a slot shape. That same M2 slot can support either a SATA drive or an NVMe drive. And from the outside, you cannot tell which one yours accepts just by looking. The drives look nearly identical. The slots look nearly identical. But they are not the same. Buy the wrong type, and it won't work at all. No workaround, no adapter. Always check your motherboard specification sheet before ordering anything. That one step saves a lot of frustration. M.2 NVMe SSD. This is where the conversation completely changes. Instead of routing data through the older SATA pathway, an NVMe drive talks directly to your CPU through the PCIe lane. The speeds are not slightly better. They are in a different category entirely. A mid-range NVMe drive hits 3,000 to 3,500 megabytes per second. Gen 5 drives crack 7,000. SATA tops out at 550. That's not a marginal improvement. That's a different world. Why people love it is partly performance, partly timing. NVMe is now the default storage in most new laptops and desktops. If you bought a machine in the last 2 or 3 years, there's a good chance one is already inside it. It's become the new baseline for what a fast system is supposed to feel like. Here's the honest part, though. For email, YouTube, and writing documents, you will not feel the difference between NVMe and a good SATA SSD in daily use. The speed shows up in demanding workloads, 4K editing, large transfers, virtual machines, not in opening a browser tab. If your workflow never stresses storage, you're paying for headroom you may never use. What you are paying for is the future. NVMe is the current standard, and it's not going anywhere. Choosing it now means your storage won't be the bottleneck for years. If you're building a new PC right now, go NVMe. Don't overthink it. PCIe SSD. Most people watching this will never buy one of these, but understanding it changes how you see everything else. A PCIe SSD installs directly into a full-length PCIe slot on your motherboard, the same slot your graphics card occupies. It's not a compact stick. It's a full add-in card designed for machines that need storage performance at a scale M.2 alone can't always deliver. Why it exists is a combination of legacy and ambition. Workstations built before M2 became standard still needed fast storage. And for professional workflows, genuinely bottlenecked by throughput, video pipelines, scientific computing, large-scale data processing, this is a real solution to a real problem. The limitation is significant. It consumes a PCIe slot that could hold a GPU or other critical hardware. It's bulkier and more expensive than an equivalent M.2 solution. And for the overwhelming majority of users, complete overkill.